All right, here we go. Day 3 for differential equations. We are going to look at solving for the particular solution to these differential equations. So the particular solution dealing more so with exponential growth. Okay, so exponential growth. All right, here we go. First of all, knowing how to write a problem from what has been given, let's look at this right here. The rate of change of the number of bacteria y. How can I write that from what you read? Y prime, yep, or dy dt. You with me? So dy dt is what I just read. Is equals k. Directly proportional, we multiply, and we're going to multiply with the bacteria present. And the bacteria present we can call what? Y. Nice. Differential equation was created simply from that first sentence. Okay, here we go. Our goal is to find a formula that will give me the bacteria at any time. If you chose b as your variable instead of y, you'd have b. You could have b of t, which is the same thing. This is the same thing as y. This is the same thing as y of t. Okay? Our goal is to find that function that it came from. All right, so let's do separation of variables. I need to move one of these variables first before I integrate. Which variable am I going to move? T, right? I'm going to move t. Because we can't integrate when the dt is in a denominator. We only can do it when it's in a numerator. Okay? So I'm going to move this dt by multiplying, you could say, both sides by dt. So that I have this on the right side. And then I'm going to move the y over to the left side simply by dividing. Okay? So this is called the separation of variables. I'm not going to integrate. Notice the constant multiple rule of k. I did not leave it inside of the integrand. I went ahead and pulled it out. Questions from what I've done so far? Okay, so that alone is going to give you 1 point. And these are types of questions on the AP exam. So these are FRQs. This is one FRQ, and it's worth 9 points. And what we're doing in part A alone is worth anywhere from 5 to 6 points. And I'm going to highlight each point that they're looking for, that I'm looking for on your quiz today, but more so that you're going to do in groups here in just a bit on those whiteboards that you see over there that second period did earlier. Okay? Here we go. So let's go ahead and integrate the left side. What's the integral of the left side, guys?
Natural log of the absolute value of y.
Nice. Natural log of the absolute value of y. Right here, put in your notes or make note of it in your head. You keep the absolute value as long as what's inside of that absolute value is still a variable. So if you plugged in a number, let's say you plugged in -5, not only would you have made it a +5, but then you will change that to be parentheses. But as long as that variable is variegated, it's remaining as a variable, please leave it in absolute value. Okay. What's the integral of the right side? kt. And then? Plus c. Yes, put the c with the x, okay? Yes, there's a c technically over here on the left side, but if I subtract it, no, it's not 0. It's still c, okay? But we're not going to write that over here on the left side. We don't need it. We'll just say that the c is on the right side with the t, okay, with the input variable. All right, so this right here, the second step that I just did, is now the second point, again, of these 5 to 6 points that we're trying to accumulate. This right here, when you do it in your groups here in just a bit with your presentations, is going to be called the general solution. Just like when you were in Algebra 1 and you got an equation that looked like this, that's a general solution. That's a B, by the way, not a 6. You would need a point to solve for the particular, which is the y-intercept over there. Here, we need a point. And luckily, I have 2 points. And the reason why I was given 2 points It's because I'm going to need to use both, and I have to use them in a certain order to be able to solve for my variables. What variables do you see in the general solution right now that I need to solve for? C and K. So K is a new variable. With the homework that you've been working on, you've been doing a lot of just C's. Now we have a C and we have a K. Okay? Alright, so from these 2 points that we were given, 0, 2,000, and 3, 10,000, guess which one we would most likely have an easier way to solve this out by using first? 0 and 3,000, or 2,000, yeah. So let's put 2,000 where y is at. So it would be the natural log of 2,000 with parentheses. I'm going to plug in 0 for k, or for t, sorry. And then I will solve for c. So right now what I just did, I know some of you can do that in your head, but they will not give you the third point unless you do it. Okay, so plugging in that initial condition after you get your general solution, that is your third point of these 5 to 6. Yeah?
Would it be okay if we wrote it like y equals e to the kt plus c?
So don't go there just yet, okay? And that's a really good question. Some people like to get y alone as fast as they can. And here's what I'll say. Try to leave your general. Your general doesn't have to be y is isolated. You can leave your general exactly like this, and I think you should, because of the kind of negative mistakes people can make if they try to do that, getting y by itself, okay? And I'll show you how in just a bit, okay? Any questions right now? Okay, so here we go. We now plugged it in, and the reason why we plugged it in is so that we could find the value of c. You guys tell me, what's c equal? Yeah, natural log of 2,000. So c is equal to the natural log of 2,000. So what I'm going to do is I'm going to make this general solution, and you'll put this in your presentations here in just a bit, into a particular solution. Okay? So I'm going to have the natural log of the absolute value of y is equal to kt plus the natural log of 2,000. Now this is a little bit more exact, but it's not the particular quite yet until I find k. Okay, so we could say it's almost the particular solution. We just need to solve for k. How do I do that? Plug in the other point. We're going to plug in this other point right here, where t is now 3, so we would have 3k plus the natural log of 2,000 is equal to the natural log of, not only will we take the absolute value of this, which is still going to be a positive, but we're now going to put a parentheses, because it's not a variegated variable. Bless you. And there it is. This is almost the particular solution. I mean, it is, but we got to get y by itself in the end. Okay? Why did we do this work just now? So that we could solve for our second variable of k. Okay, here we go. Let's combine our natural logs. What am I going to do to this natural log? I'm going to subtract it. So if I subtract natural log from the right side and I move it over here, what am I doing with 10,000 and 2,000? Dividing. So 10,000 divided by 2,000? 5. So that's a natural log of 5 is equal to 3k, and therefore k is equal to the natural log of 5 divided by 3. Now I can take this almost particular solution, and I'm going to use this k that I found as my, you could say, proportionality constant right here, and then I have my equation. I just have to get CO by itself. Go with me? Yeah.
So I have a question about like rewriting logs. So in this example, it's 1/3 natural log of 5, right? Could the 1/3 technically be the exponent for that?
1/3 times the natural log of 5 is the same as the natural log of 5 to the power of 1/3, and that's a huge skill, good timing too of bringing it up, that you need to know how to do.
So it has to be inside the parentheses to bring it
Bring it down. Yeah, yeah. So this right now, let me go ahead and start rewriting it in our almost particular solution here. And then you'll see the simplifying part. That's pretty algebra intensive to finish this off. Okay? Alright, so we're going to plug in, I don't know why I did that. I erased it. So I need to put in 1/3 the natural log of 5 times t. And all of that is representing our k, our constant that is in front of t. Okay? We're going to do what Braden said in just a bit as far as simplification goes. But are there any questions that you guys have right now? Okay, so let's go ahead and go to getting this alone. Okay, so you know how we plugged in so that we could solve for k? The work that we just did that I erased, all that right here would also be similar to this work. So that could be your 4th point. Okay, so we need 5 more to go, or 2 more to go. Okay, so let's go to finish this off. Our goal now is just to get y by itself. Okay, what do I do from this point to get y by itself? Yeah, I'm going to apply e as the base of all of this. I'm going to apply e as the base of all of that. It's been a minute, but if I had e to the power of 2 times e to the power of 3, this is the same as e to the power of what? 5, because you add their powers. Okay? And all we're going to do is we're going to go from something that looks like the adding backwards to create 2 forms of multiplication over here on the right. Okay? So let me do this in blue. This one will become t over 3 times the natural log of 5. The other one is natural log of 2,000. Can you tell me what's on the left side?
Y.
Almost. The absolute value is still there. We have to contemplate that here at the end. Okay? These cancel, and 2,000 comes down. You with me? So let's put 2,000 right here. Now, just like Braden did when he put this as the power, like over here, 5 to the power of 1/3, we can look at this as natural log of 5 to the power of t over 3. Go with me? So if I apply a base of e to this piece, these cancel and the 5 comes downstairs. Why do you think I did 5 and 2,000 in 2 different colors?
Because 5 is a base of the power, so you can't multiply the power.
Exactly. This will not be the same as 10,000 to the power of t over 3. You have to do PEMDAS first, so you're going to leave it written like this, because this right here is your exponent piece. It almost feels like when you were in Algebra 2 and you did PERT, P was the principal, E was the base, and it was like to the RT. Okay? The RT is applied to E base first and then multiplied with the principal, in this case 2,000. Alright, so here we go. Now I'm going to take off these absolute value pieces, or symbols if you will, but I have to make a choice. Does that make that a positive or a negative 2,000? Okay? If you've forgotten why there's a positive and a negative, please remember that quadratics, what's the answer to that? Plus or minus. And this is similar. What's the answer to that? Plus or minus 81. So because there's a plus and minus that we're contemplating when we take off this absolute value symbol, we have to ask ourselves, what belongs there, a positive or a negative? Anyone, what would I put there? A positive. And the reason why you know it's a positive is because you can test out one of your original points. I would test out this one right here. So if t was 0, 0 divided by 3, 0, 5 to the 0th power, times 2,000, a positive 2,000. Do y'all see that? So this would be my solution to the differential equation. Okay, so 1, 2, 3, solving for k was that fourth, and then you can say this could be the fifth.
Did you say there were 6?
Yes, because technically this is the fifth one, and getting it all the way down to y is the sixth one. You with me? You could have written y, you could have also written y of what? T. Are there any questions from all of this? Because you're going to be recreating this in groups here in just a bit.
You said that one's the particular solution?
This one's the particular solution, yes. The particular one, it does. The only variables it has is an input and an output. Just like you've been used to. If I give you 3x plus 5. Only two, an input and an output. Questions? Fairly easy, right? So if I asked you, B, how many bacteria are present at 5 hours, what would you do? Plug in 5 for T, see what your rounded answer would be. If I said, find the time where 35,000 bacteria are present, what would you do?
35,000 equals.
Yeah, 35,000 is your output. Menu solve feature, solve for T. Cool?
Very cool.
Alright, so let's move on to the next one. Okay? And then when we do the presentations here in just a bit, it's so that you can see all the little details in problems without having to do so many homework questions. In fact, we're only assigning you 4 homework questions from today's notes. Okay? Alright, here we go. So the rate of change of the number of bears n is directly proportional to this. What equation can I create? Yep, dn dt equals k times
1200 minus n in parentheses.
nicely done. Okay? Again, when you see the word is in this context, you're to interpret this as equals k. Inversely is dividing, directly is multiplication. And you already know the rate of change of n is dn dt. Okay, here we go. So when t is 0, there are 300 bears. So already I have that first point. And then whenever there's 4, I have 600 bears. Find a formula for the number of bears at any time t. Okay? What should I do?
Distribute k.
Okay, so I could distribute the k, but here's what I'll say. Does it matter where k goes? Can k go on the right? Yes. Can k go on the left?
Yes.
Yes. Where is k easier to work with?
On the right.
The right, because it's in the numerator. You with me? Okay? So let's leave k alone. We don't have to distribute. We're going to break this little glue of multiplication up by moving the 1200 minus n to the left. So we have dn over 1200 minus n. This is what we're going to integrate from the separation of variables. So I'm going to move the t over to the right side. So I'll have k dt, and I'm integrating. You with me? Alright, so here we go. What's the integral of the right side?
Just k times t.
Kt plus c. Because k is a constant. Yes.
So you wouldn't get points off if you put k inside the integral sign, right?
No, you wouldn't get points off. No. That's just me, again, reinforcing what we've talked about with constant multiple rule to make things easier for you. Alright, so over here, I'm going to do a little u sub, right? So u is what? 1200 minus n. What's du? Negative
dn.
dn.
Can you not just do natural log the absolute value?
And I could do that. Say again, what?
Can you not just, since it's like 1 over 1200 minus n, can you do the natural log the absolute value of 1200 minus n?
I'll get to that here in just a bit. There is a shortcut to it, but let me tell you, that's why we have to do U sub. And you probably already know it. You probably have seen it. You've seen it with the homework, maybe a little. But I want to tell everyone at the same time. All right. So the rewrite. The rewrite would be 1 over u dn, or sorry, du, with this negative out in front. Okay? So this right here is almost a precursor to what Braden's saying as far as what the shortcut could be. It's a 1 over the natural log, or sorry, it's the natural log of the absolute value of u plus c with this negative out in front. Okay, all we care about is the negative natural log of the absolute value of the u that we have over here. And that u was 1200 minus n. If you haven't already discovered this, the shortcut is this. From here, if the bottom function is a u, and I can see it, like a 1 over u, natural log of absolute value of something interpretation, it all depends. I can make it easy if I can see that this is a positive. If this is a positive 1 in front of a linear n to the power of 1, then it's exactly what you said. It's just the natural log of the absolute value of the denominator. But if it's more involved than that, and you're afraid of making negative mistakes, do the u sub. Otherwise, it's just the negative form of that. You see what I'm saying? So it will be the natural log of the absolute value of 1200 minus n with a negative in front. Please tell me, why did I still write this absolute value? Because I have n. N is still a variable right now. What do we call this right here that we just found? General solution. Okay? Okay, so right now, and I think I might have been a little bit different on the other one, but this one should have been the first point. This would have been the second point, and this would have been the third point. Now let's plug in a point so that we can solve for our variables, k and t. Which point should I plug in first? 0, 300. And the reason why we do 0 is because this 0 will make this entire thing turn into 0. And we no longer have to contemplate k. Okay? So it'll be 300 is now going to be plugged in as the y value, or the output. So what does that become? The natural log of the what? 900. So the negative natural log of 900 in parentheses is equal to c. Okay? And yes, I know it's stupid, but I want you to do it the way they want it on AP to make sure you get all the points for work in that process. Okay? So this would be your fourth point. Looking at using one of the initial values or using one of the initial conditions to solve for your t. So let me highlight that orange. Or maybe not. Are there any questions so far what we have? I mean, it's pretty straightforward. Alright, so now we're going to build the general solution to become a little bit more particular by plugging in the value of c that we discovered. And we would have, okay, so again, we are plugging this one right here with that negative right here. So that I have negative natural log of the absolute value of 1200 minus n is equal to kt minus the natural log of 900. It's almost a particular solution. I still need to solve for what variable? Okay. From what your experience from calc so far has led you, what would you probably do right now to make this a little bit, quote unquote, easier to work with? Divide both sides by negative. Or multiply both sides by negative. So if I do that, it will get rid of this one. It will make this a positive natural log. Okay? Whoops. And then it will make this a negative kt. Are we good?
Why did we do that again? Oh, to get rid of the...
Yeah, the reason why I like to have you guys do that is because when you apply the base of e to a positive form of that, it's easier to interpret what comes down. You see what I'm saying? Otherwise, we're working way too many negatives all at the same time. Okay? So now, here we go. I applied e as the base to the left. What's the left side simplified to, guys? The absolute value of 1200 minus n. That's the left side, because these canceled, right?
Why are we doing this before we solve?
Oh, my bad. I'm doing it a little bit too early, my bad. I gotta plug in. Thanks for finding that, or seeing that. I gotta plug in my other point. This one right here. Okay? So let's plug in. Let's go for 4 is going here. 600 is going here. So it's the natural log of 600 is equal to negative 4k plus the natural log of 900. Subtract the natural log, divide, what does it reduce to? 2/3. So the natural log of 2/3, which is 600 divided by 900, is equal to negative 4k. So k is the negative 1/4 natural log of 2/3. Easy, right? So now let's plug in this k value up here where we have that almost particular solution. Okay, let's see what we write. It will be the natural log of the absolute value of 1200 minus n, everyone, is equal to what?
Can you already put it
Is that gonna be a 4?
Do y'all see this negative
Yeah, it's gonna be positive.
and this negative? So it will be a positive. And we can go ahead and write it right now if we want. It will be a positive
T over 4.
t over 4 natural log of 2/3. And we're going to move it. Yeah. We're going to move it as the power now. So we're going to move this to say that this is the natural log of 2/3 to the power of t over 4. Because when we apply the base e, it'll be easier to simplify. Okay? So let's go ahead and write that out. So the natural log, let me do that in red. The natural log of 2/3 to the power of t over 4 plus the natural log of 900. Any questions? Okay, what do I do next? E-base. I'm going to apply E-base to the left and to the right. Remember, on the right side, because of this addition in the power, it's the same as having multiplication between two bases. So e to the power of natural log of 2/3 to the t over 4, and then e to the natural log of 900. What is this simplified to? 900. I'm running out of room. Let me write over here. And what is the other one simplified to? 2/3 to the t over 4. And the left side? Yep, still that absolute value. Any questions? Alright, so the last part of this, we're almost done, is that we have to decide when I take the absolute value sign off, when I take these two pieces right here off, I have to decide if that's going to be a positive or a negative. Okay? So let's go ahead and do 1200 minus n, and then we'll do 900, 2/3 to the power of t over 4. And let's go ahead and use one of our points. We can use any one of these. I'd probably use the 0 because it's easier to one out or zero out a bunch of things. And here we go. 0 would go here for t. 0 divided by 4 is 0. 2/3 to the power of 0 is 1. So 900 would be on the right side. And 3 would be the y value, would give me 900. So you tell me, from that, does this have to be a positive or a negative to make it work?
Positive.
It has to be a positive. So that my interpretation will be a positive right here. Then I can just move things simple, algebra 1 stuff, and get n all by itself. Okay, so let me go ahead and make some room for that, because I'm wanting you to show all this work so that you can get the full points, because we max out on these questions. They're easy, easy money makers. Let's subtract 900 to the left side. So you have 1200 minus 900. And we have to the power of t over 4. Then we would add n to the right side, but instead of writing n here, just so it's like what we're used to reading, I'm going to write it here. And I can put n of t. And there is the solution to the differential equation given those 2 points. It's just a lot of work, but it's easy. I think the hardest part is people remembering their algebra 2. Questions?
What would it have told us or given us if it was supposed to be negative 900? Like, how would we have known that?
Because it could have, like these numbers that they give you will have negative pieces to them. You know what I mean? And I know that the context of this one, it doesn't make sense to have negative. But, if, you know what I mean? It could be given to you in that way. Okay? So 1, 2, 3, 4. 5 to get the k. And then 6 to get that piece right there, and then you're good to go. We good? Okay. So now what I want you to do